When a subject deletes their search history or uses incognito mode to plan a crime, they assume their digital footprints vanish. But modern web browsers silently write a resilient, chronological map of activity to deep system databases, turning the very tool used for concealment into the ultimate forensic witness. Welcome to reWant, Courseware, an AI-narrated video series unpacking the latest lectures and thoughts from Professor Adam Scott Wandt of the John Jay College of Criminal Justice in New York State. Today, we are looking at Module 13, Browser Forensics. Nearly every aspect of modern financial fraud leaves traces inside a user's browser profile directory. Hidden deep within these directories are SQLite databases, files with names like history, cookies, and login data that record the specific research, planning, and execution steps of an illicit scheme. Locating these hidden files is only the first step. Before examining a single byte of data, an investigator must establish explicit legal authority. Depending on the investigation, this means securing a search warrant, verifying a corporate acceptable use policy, or ensuring strict compliance with the Electronic Communications Privacy Act. Because these databases store deeply personal and protected information, the access process is highly regulated. A successful forensic investigation requires executing precise technical extractions while simultaneously navigating complex constitutional law. Once legally acquired, examiners must interpret how different browsers architect their memory. Chrome and Edge separate their history into two distinct tables, URLs and visits. Firefox consolidates this architecture, storing bookmarks and history together in a single file called places.sqlite. Inside these tables, timestamps appear as massive strings of numbers. This is the WebKit epoch format, a system that calculates time by counting the exact number of microseconds that have passed since January 1st, 1601. An investigator translates it to reveal the exact second a page loaded. Using forensic software, examiners extract and cross-reference these timestamps against visit counts and download logs, outputting a unified chronological timeline detailing every action taken on that device. Many suspects attempt to break this timeline by relying on private browsing or incognito mode. While these modes prevent the browser from saving history directly to the drive, they cannot shield activity from the rest of the operating system. Even when a session skirts past the hard drive, the data is trapped elsewhere. Investigators simply pivot to alternative sources, extracting residual artifacts directly from the computer's temporary RAM, the Windows DNS cache, and system prefetch files. Extracting an artifact, however, does not immediately close the case. Forensic examiners operate under a strict rule. There is a vast gap between what an artifact suggests and what it actually proves. Take saved passwords as an example. Finding a credential stored in the Windows Credential Manager proves an account is associated with a specific device. It does not prove a specific person actually logged in at a specific time. The same logic applies to cookies and download logs. A tracking cookie shows prior interaction with a website, but not the identity of the person sitting at the keyboard. A download record proves a file was retrieved from the internet, but tells you nothing about what the user did with that file afterward. Because of these limitations, isolated browser artifacts remain circumstantial evidence. To build an airtight narrative of user intent, an investigator must weave these data points together with network logs, system activity, and external provider records. This demand for corroboration is highly visible in the courtroom. In the insider exfiltration case against former Goldman Sachs programmer Sergey Aleynikov, the browser history alone did not meet the burden of proof. It only gained its evidentiary weight when investigators paired his web research directly with the file system metadata tracking the stolen source code. Similarly, during the Silk Road dark web investigation, the FBI could not rely on a single digital artifact to identify its operator, Ross Ulbricht. They constructed an aggregate digital timeline. By correlating years of specific browser activity, system usage, and disparate network logs, they built the legal connective tissue required to link an anonymous online marketplace directly to a physical person. More recently, during the 2025 Brian Walshe murder trial, prosecutors introduced dozens of Google search queries detailing body disposal as direct proof of premeditation. Introducing that evidence required passing rigorous courtroom scrutiny. The defense cross-examined the digital forensic witness on the exact scope of the extraction warrant, the accuracy of the timestamp conversion, and the difficulty of attributing a specific search query to a specific suspect on a shared household computer. Looking ahead, the sheer volume of data is pushing the field toward automation. Investigators are increasingly deploying AI-assisted forensic tools to process massive browser datasets and instantly flag suspicious behavioral anomalies. Yet, despite the speed these tools offer, strict human validation remains mandatory. An examiner must independently verify every AI-generated lead before it can be used in court, ensuring the methodology meets legal admissibility standards. Modern web browsers write a permanent, granular record of user activity, but a conviction relies on the investigator's ability to legally extract, correlate, and validate those traces into a reconstruction that survives the scrutiny of a courtroom. Like, follow, and subscribe for more deep dives into emerging technology, digital investigations, and the ideas shaping our future. And remember, stay curious and want knowledge.